everybody. Hello. Thanks for being here early in the morning. And we hope to excite you with some things going on in new technologies today. I have the privilege of introducing Shoji Satake. And I was trying to remember the first time we met. It might have been over an NCECA board meeting of some kind. But I've also interacted with him in China. And what I find is that he wears many hats, and he wears them well. Shoji teaches at the University of West Virginia, and their ceramics program, of course, has a national reputation. He has served as director at large for the NCECA board, and besides that, he has a very active studio practice, and he exhibits on an international basis. He's coordinator of the School of Art and Design's Ceramics in China program in Jingdezhen, China, and I recommend that program to students all the time as a place to experience China and its ceramics culture, as well as a chance to work with Shoji. Shoji is I was trying to think of what I would call you, an instigator, initiator of this amazing Fab Lab, and he's brought together like-minded people working in new technologies for both our work and for the future of our students. And so I want to both thank him for this and to give him a warm reception for this presentation.
Thanks, Anna, for that introduction. We are recording this, right? So,
we're video streaming.
Right. We're live streaming this on the 92nd Street Y, so you may be joined by millions of people from around the planet, right? Who knows? But thanks for that introduction, and thank you for coming this morning. And this whole Fab Lab thing is a 3-year project, which kind of stemmed from all the great presentations and the panel discussions we've had on digital technology at the conference. But I was frustrated about how there wasn't a lot of art being made and being able to present a lot of this work and how it was being done. And so this was kind of a conversation that we've had and became a byproduct of it. And I'm really thankful for all the artists that have been involved and willing to come and spend their time here. And thank you guys for coming. So my talk's a little bit more altruistic, and it tends to be, it's more in layman's terms. So I'm an artist and professor at West Virginia University, and really whether adapting a traditional arts practice to embrace new technology or bringing new technology into the art studio, I, as an educator, must embrace the fact that the current generation of learners will view nature and creativity differently. So creativity's role in higher learning and workplace are viewed as essential rather than an optional add-on to enrich core curricula. And so how do I do that? And despite the rapidly changing environment for art and learning, many are really confronted with obstacles to acceptance and application of new technology. And I think we don't have much pushback on this as I think we used to when a lot of us started these projects. And I think it's because when you're exposed to new technology, we're all afraid of those things, right? We have to learn new ideas, and we don't have to reinvent the wheel, but we have to rethink about how we walk again, or how we run again, or how we swim again. And so I think this has been out enough now that I think people are starting to embrace it, and the idea is that this technology is here to stay, and it's only going to get better. So my talk today is about how artists like myself, and as an educator, use this science and technology to create interesting and beautiful objects of art, right? And if any of you were here yesterday during the lectures, you heard from what I believe to be some of the most beautiful and the smartest minds in our field that are kind of embracing this technology. And I don't pretend to be either of those two things, right? So my conversation with you is more about, in layman's terms, how do I engage students to think beyond the box and use this digital technology as another tool? The way I like to think it is that, I might not be the smartest person in this room, but I'll try to be the hardest working person in this room to make it better. So I see these digital tools as another extension. It's like an extruder. It's like a potter's wheel. It's like a slab roller. It's like our hands, right? It's to do something really, it's another way to make things that are really creative. And I'm a true believer in the notion that given time, anyone that wants to do this stuff is an asset. And if they really become engaged in this conversation or in this kind of practice, they're really going to find ways to really impress you. And quite frankly, my students are way smarter at this stuff And they're teaching me new things all the time, right? Because this is from their generation and not from mine, right? So to go back a little, step back a little bit, rapid prototyping is a word that gets thrown a lot these days, right? And especially when we talk about digital technology, 3D printing is also known as additive manufacturing. It's AM, right? It refers to various processes used to synthesize three-dimensional objects. But it's not a new idea, right? It's an idea that's been around for thousands of years. Much of its history still thrives in places like Jingdezhen, where we take our students, where it's about this mass production, design, mold making, maybe not done with the kind of the advanced technology, but it's still being done and to create works of art. Right? So this is another extension of that. So in the early additive manufacturing, equipment and materials were really developed in the 1980s. In 1981, Hideo Kodama of the Nagoya Municipal Industrial Research Institute invented the AM methods, right? And so fabricating methods of three-dimensional plastic models with photo-hardening polymers were what he was doing, which is the exposure of UV exposure to mask patterns or scanning fiber transmitter. And that's like what the Tevon 3D has been really revolutionary, using the porcelain material and using the UV methods of resin printers. And they become really affordable. And this image is here is one of my former students working on one of our earlier projects. And when we got into 3D printing, it was just buying these kits that didn't really do much, right? And so clay is really one of Earth's most common materials, and it's embodiment of our most enduring cultural expression. And it's really archival, right? And this new approach joins material and technology to artistic traditions, expressions, and innovations. And the response to new technology and their application to ceramic art and learning represent underexplored, exciting aspects of the field that will influence its continued evolution in the 21st century. So how do you integrate this into curriculum? How do you buy or raise money to buy the equipment? Right? So 3D printable models may be created with computer-aided designs or CAD packages. Right? And much of the software is open source and it's free. You just have to look for it. In fact, if you have a university or school, high school, K through 12, like an EDU email address, Autodesk provides all their software for free for up to 3 years, right? Every single one of their software. And so you can just go and download it. Just plug in your EDU address when you're a full-time student or a full-time faculty member or staff member at a school, and you'll get all that stuff for free. So that includes AutoCAD, Maya, Mudbox, AutoCAD 3D Max, Fusion 360, to name a few of their applications. So I think one of the most intimidating things about 3D digital technology is that how do you navigate through all that information, right? And how do you learn this stuff? You know, quite frankly, when we started, there was like no classes teaching me how to do this. And so, but it's much like what we do here at this conference or what you guys do in your own studio practice. And basically, you start by learning from tutorials, workshops, and quite frankly, a lot of YouTube videos. Right? So, but it's much the same way we're actually practicing in our studios, right, as artists. So one of the projects that we do in my class, or when we teach those 3D classes, we actually mock up a spaceship on Maya, and then I show a demo, like a really quick 7-minute demo on YouTube without the sound on it, and then I replay that video again with the sound. It's basically a 7-year-old kid teaching us how to make a spaceship. Right? And he does it in 7 minutes, and he's more proficient than any of my students or myself. So these examples are models that are created on the computer that can be used with machines like the CNC, like Andy's machine, to deductively carve and create art, molds, decoration, etc. And this is like one of Andy's beautiful pieces. This style of working, learning, really in the STEAM fields, right? That we hear STEM a lot. By trying to figure out a way to add that A into STEAM, and is really it's incumbent on us to it's a role that we have to play through our entrepreneurship by creating research and disseminating out-of-the-box learning system to encourage people to think in that way, right? And it's this multidisciplinary, collaborative, adaptive, and it's replicable, right? And those are the things you have to say when you're asking for that money, when you're approaching your administrators. And it's a way to say, let's learn in a way that it's fun, right? So the idea of integrating arts into science, engineering, math, right? Teach them something by teaching them something else, right? So what we've been doing is we're initiating a statewide maker fair at my university. And so we're encouraging all the students, K through 12, and our university students to get involved and send products, 3D printed objects that they can actually make on their computers and send it to the university that they can, have people like Shapeways, who's one of our underwriters today, print them out. And then, so they don't even need a printer at home, right? And then send it to this contest, and we're having judges. We're having different categories on artistic merit, on the simple design tools, and things like that to try to get them excited about this idea. They may become our future engineers, they may become our future doctors, but they also may become some of our best artists. And so digital technology and the intuitive science-based learning is really another window for us as artists to gain internal, state, regional, federal, and foundation grants. So, everybody loves words like technology, science, digital, right? So it's become really increasingly popular to start creating objects in the plastic filament 3D printers, right? These are things that you can buy now. They're really affordable and can be purchased as plug and plays, right? If you have a little bit of rudimentary software knowledge, or you download some stuff off the Thingiverse, or people are uploading all their models, you can download that stuff for free and you can have it printed, right? And you can buy this stuff now at Lowe's, Home Depot, and other large box vendors, and they're selling all this stuff online. But as a ceramic artist and a teacher, my approach has been, how can we use that technology as another tool to help create beautiful objects of art? So these printers, like the clay printers, print in layers to create 3D objects, right? And you can use things like the 3D scanner, I think Greg talked about yesterday a lot during his presentation, or use a plain digital camera and photogrammetry software. The manual modeling process of preparing geometric data for 3D computer graphics is really similar to ceramics. 3D scanning is a process of collecting digital data on the shape and the appearance of the real object, creating a digital model based on it. So those scanning cameras, right, basically are taking thousands and thousands of pictures per second, and they're basically stitching all that stuff to create a three-dimensional image on a two-dimensional format. So, you can get apps like this on your smartphones now, right? And they'll get better and better, and there'll be more of them. And then, right, as a professor offering these kind of opportunities to our students, it's really to directly build future interest through like year-round activities and offerings. They may not have access to your ceramic studio during the summers or during Christmas break, but they can still do this kind of stuff on their cell phones. They can do it on their computers. They can continue to think about ways that they can make work, right? It's also a way to tie in keywords for grants such as global learning, advanced digital technology, collaboration, right, and STEAM research and not STEM. So I've accepted that this technology is not going away, but it'll become far more advanced and way more sophisticated than it is now, right? And so, in fact, by the time my kids, who are right now 3 and 1, are adults and buying their first home, they will most likely expect and have a 3D printer probably sitting next to their microwave in their kitchen, right? And if they lose a button, a handle, a knob, right, or they want to print a new Christmas ornament, replace the handle on their toilet, before they go to work, they're just going to download it online, pay for it, and then push play on the 3D printer and go to work and come home one day and it'll be sitting there, right? And that's the direction this stuff is all going. So how do we as artists, as educators, use this tool to produce learning outcomes and tangible results that benefit society? Right? That's what I'm most interested in. And so, as many of the artists yesterday reaffirmed, these machines are actually brilliant and quite stupid at the same time, right? The machine will only do what the human mind has commanded it to do. So the idea is to use these tools to inspire and spur activity and creativity that is in all of us, right? To put it into perspective, the potter's wheel is basically the most perfect circle or cylinder making machine ever devised by man, right? So, but it's also in the 30,000 years of history, right? The invention of the potter's wheel is only about 2,000 years old. So it's relatively new technology, right? And so this aluminum sphere, for example, was printed in plastic, then cast in rubber, right, to create a mother mold and subsequently cast in metal, right? And it easily have been done in slip casted clay or a press mold. So these are plastic 3D printed stamps that we use to create these clay tiles, right? So ways to think about it, so it's not an end all, right? It's another extension of the things that you can do with your minds. And So from the knife to the hammer to 3D printer, the influence of the tool on the design is not to be underestimated. Yet for a long time, the instruments of production were closed systems, right? So what I love most about this technology is that it's ever changing, right? Following the personal computer and range of digital advances, the advent of a personal fabricator has provoked the revival idea of making your own things. So there's new species of design, semi-industrial craft, and although definition of craft often refers to work by hand, in this context, it reflects a renewed interest in building knowledge through repetition and practice of skilled trade using the aid of tools. Right? So in recent years, 3D printing has gained really a lot of notice in the press and in the public. It has undoubtedly already transformed prototyping, manufacturing, engineering, will continue to change many other industry, and you see a lot of the artwork that's being made today by some of the artists is represented here, and by others that are not in here, and hopefully they will be involved in our future projects. So in 3D printing, successive layers of materials are really created under computer control, but they require us to do that, right? These objects can be almost made any shape of geometry and produced from 3D models. And so the 3D printer is really just another industrial robot. It's another tool. It's another bag of tricks. Right? So the potential to print an interior from the exterior form is what's the real potential of this equipment. And then my introduction to all this stuff was because of my wife actually taught at Bowling Green State University, where John Balistreri was. He was one of the forefronts of using the Zplotter to create the ceramic powder printing, which is now transformed into Tevon 3D. And so it's really limitless. So these great advances in 3D printing technologies that the designers and makers have created open source platforms not controlled by a few companies. So a lot of this stuff is free for everyone to actually open source and find out on their own. And so, like I said, you don't need any of this stuff. If you just have a computer and use one of the open source free software, you can make some stuff and send it away to companies like Shapeway, a third-party printer, and then plug in your credit card number, and then they'll send it back to you in a few weeks. Right? May not always be the things you want, but and then the fact that depending on the materials you use, it can range from a few dollars to several $1,000s, depending on the materials you have printed in. And in fact, we have 2 of those machines that Brian Sebas has built, and we're building a 3rd one, and I'm hoping that eventually we're going to be printing like in chocolate and stuff and see what that does. So these are a few more examples of some of the amazing works of art that people have made and the potential of this idea. And so really quickly, my research, like I said, is really about to figure out ways how I can incorporate this technology to create an object that really enhances my work as a sculptor. And I really still kind of at a crossroads. I really don't know what that means or how it's going to work in my work. So, but this is an example of the things that Tevon 3D makes. And I had an opportunity to go and work with them. They have a great residency program that you could go live there and work with those artists and then their technicians, and they facilitate projects for you. And Brian Harper and we were the first 2 guys that went and did it. And it's a really amazing experience. And so through that, I bought refurbished 3D printers, the Zplotters, and we've been working with those things. I was able to acquire some funding to get a postgrad fellow, Kelly O'Brien, who's been, she's right there. And she's been our tech, and she's been brilliant. And she can tell you the huge learning curve at the beginning, but once you learn, it's actually relatively easy. It's about maintenance. And so this machine example is over 10 years old, and it's been around for a while. Now, and it was initially made for gypsum printing with plaster, and now we're printing it with a clay powder. So when I began this research about 4 years ago and spent a great deal of time learning how to use this technology, it really became this idea about using another tool. So for me, just creating objects like these were not an end-all for me. There was still a void. They seemed really cold and sterile, like the machines that were really creating them. So I had to figure out ways to really think about the way I looked at this stuff. So when I was at Tevon 3D doing my residency with them, Brian Harper and I kind of started talking about some of the human interactions and how we can be involved. And I work at a top-notch research institution, just like Anna does. And I was able to collaborate with my bioengineering department, and we extracted my DNA. And so we started to map out my dendrites and figure out a way to 3D model them. And so now I've been modeling a lot of those things. And as you know, dendrites are branched projections of your neurons that act to propagate those electrochemical stimulations that receive from your neural cells into the cell body. Right? So your signatures are very unique. And so I started to model those things and then started incorporating and embedding them into my work. And so every one of those things has my dendrite signatures in them. And these, a lot of these parts have been printed in ceramic printers and this hand-built slip cast. So it's a combination of all those things that I use to make what I feel is more unique. So it's just one of the many components to create my sculpture, right? And that's how I look at it. But you see the many examples and facets of people working here today, and I hope that you guys can continue to stay here throughout the day and check out all the demonstrations that will be happening today. And that's the end of my talk. But I do have one more image. This is from, these are things that are available online, for example, how to build these things. This is from Jonathan Keep's website, and Brian Sebas has all this stuff open source on his platform, and he even provides links to where to buy all this stuff and the budget, so that everybody's really sharing a lot of this information. So it's not hard to get involved if you're really interested. So thank you very much.